What are the key unit conversions for thermodynamics? Imagine trying to solve a puzzle where all the pieces are in different sizes and shapes. That's what working with thermodynamics can feel like if your units don't match up. Today, we're going to break down the main unit conversions you need to understand to keep everything consistent and clear. Whether you're calculating heat transfer, pressure, or energy in a closed system, knowing how to switch between units makes your work much easier. Let's start with energy. In thermodynamics, energy is most often measured in joules in the International System of Units. But you might also see British thermal units, kilowatt-hours, or gigajoules. For example, 1 kilowatt-hour equals 3,412 BTU, or about 3.6 megajoules. 1 BTU is roughly 1,055 joules. Converting between these helps when you're dealing with different systems or data sources. Temperature is next. It can be in Celsius, Fahrenheit, Kelvin, or Rankine. Kelvin and Rankine are absolute temperature scales, starting at 0, which is absolute 0. To convert Celsius to Kelvin, just add 273.15. To go from Celsius to Fahrenheit, multiply by 9 divided by 5 and add 32. For Rankine, add 519.7 to Fahrenheit. Using Kelvin or Rankine is essential because thermodynamic laws relying on absolute temperatures. Pressure units vary a lot. You might see pascals, bars, atmospheres, pounds per square inch, or millimeters of mercury. 1 atmosphere equals 101,325 pascals, or about 14.7 pounds per square inch. If you need to switch from psi to pascals, multiply by 6,894.76. These conversions are vital when applying equations like the ideal gas law, which relates pressure, volume, and temperature in a closed system. Mass and weight are next. Mass is measured in kilograms in the C system and pounds in the English system. To convert pounds to kilograms, multiply by 0.4536. To go the other way, multiply kilograms by 2.2046. Remember, weight is a force, which depends on gravity. So, if you know the mass, you can find the weight by multiplying by 9.81 meters per second squared. Accurate conversions here are key for energy calculations and flow analysis. Finally, volume and flow rates. Volume can be in cubic meters, liters, or cubic feet. Flow rates are often in cubic meters per second, cubic feet per minute, or standard cubic centimeters per minute. When working with gases, you need to consider temperature and pressure because these affect volume. For example, 1 cubic meter equals 1,000 liters, or about 35.3 cubic feet. Converting flow rates ensures you're comparing apples to apples when analyzing system performance. In a closed system, the mass stays the same, but energy can move in or out. To analyze these systems accurately, you need consistent units. If heat transfer is given in BTU and work in joules, converting both to the same unit simplifies calculations. Also, converting temperature to Kelvin or Rankine allows correct application of thermodynamic formulas. Pressure conversions help you use the right equations of state, like the ideal gas law, which links pressure, volume, and temperature. Getting these unit conversions right makes solving thermodynamics problems much smoother. It helps you interpret data correctly and understand how systems behave. Whether you're working with energy, temperature, pressure, or flow, knowing how to switch units keeps everything clear and accurate. That way, you can focus on the science behind the numbers and make better decisions based on your calculations.